All right, problem number 18 in group theory. Let X be a non-empty finite subset of the group G. Prove that if X is closed under the group operation, then X is a subgroup of G. All right, this is a pigeonhole type principle type problem. We're going to show that X has an identity and X is closed under, or X has inverses for every element. And we already have closure under the group operation, so we're good with that. Okay, so we're going to start by suppose that X is closed under the group operation. Then let A be in G, or A be in X. Then let A be in X. So, okay, we know that elements from X are closed under the group operation, so A operated with itself 2 times, 3 times, and so on are all still in X because we have closure. Okay. And since X is a finite subset of the group G, there exists an n greater than m greater than or equal to 1 such that a to the m, a to the n is equal to a to the m. This is the usage of the pigeonhole principle. Okay. Multiplying on the left by a to the negative m, because the A elements are being pulled from G because it's a subset of G. G is a group, so every element has an inverse. So A to the m has an inverse in G, namely A to the inverse m. So we're going to multiply on the left by this guy to get A to the n minus m equaling the identity. And since n is strictly greater than m, we know that this is greater than or equal to 1. Hence, that this is just A operated with itself to some power. Hence, the identity is in X, since X is closed under the group operation. And we're going to use the same trick to show that there are inverses. Similarly, let X be in X, then X squared, X cubed are all in X. There exists an R greater than S greater than or equal to 1 such that X to the R is equal to X to the S. Once more, multiplying on the left by X to the negative X, we get X to the R minus S equaling the identity. And now I'm going to take X to the R minus S and I'm going to multiply by kind of like the identity, but as X inverse times X. So this implies that X to the R minus S minus 1 times X equals the identity. So the minus 1 is like the inverse X, and that X would cancel out with it, giving us the identity. So it's like I'm multiplying by nothing. This implies that this. We can then multiply by this inverse on the right to get, okay, we would get X to the R minus S minus 1 equals X inverse. And we have that X to the R minus S minus 1 is in X, since X is closed under the group operation. Hence, every element in X has an inverse. Associativity is inherited because it's from G, it's a subset of G, which is a group, and we already have closure under the group operation. So therefore X is a subgroup of G. We're finished with 18.